An antenna is needed to transmit radio frequency, RF signals. Several types of antennae from various vendors are available. Which antenna you decide to use will depend on where and how you want the signal to be received. What is most important when choosing an antenna is exactly how a wave is radiated from a given antenna, which has an impact on the strength of the signal and its range. It also has legal implications because it is not permissible to radiate certain signals on certain frequencies. An antenna is a piece of equipment that can receive an AC current, and by letting a flow of electrons move back and forth, can transform this energy into an electromagnetic field. Depending on the material used to build the antenna and on its thickness, shape, length, and physical characteristics, the antenna will generate fields that have various shapes. The antennae makers create specific radiation shapes to match specific needs. For example, a maker might create a circular shape to cover a conference room or a long, thin shape to cover a long corridor. The shape is rarely simple. The internal components of antennae can cause a shape with small zones that radiate more in one place and less in another. The first task in choosing an antenna is to precisely determine its radiation shape or coverage shape. This shape is called a radiation pattern. Each antenna design produces different RF radiation patterns. One way to determine the radiation pattern is to install the antenna and then move around it with a wireless device such as a laptop to determine where the strongest received signal strength indicator, RSSI, is found. This method allows lines to be drawn, showing where and how far a given RSSI occurs. This method is tiresome. The radiation pattern would be discovered only after having purchased the antenna, and interferences could render the readings unreliable. The operation would have to be repeated a number of times to confirm a valid reading. To facilitate the decision of which antenna someone should buy, most vendors publish drawings showing the radiation pattern analysis and the antenna specifications. The analyses are done in controlled environments to avoid interference issues. An antenna radiates in a three-dimensional, 3D environment, but providing a 3D view of the radiation pattern is not possible unless the person intending to purchase the antenna has software capable of viewing something in 3D. Therefore, vendors usually provide two views: a horizontal plane, H-plane, and an elevation plane, E-plane, to describe RF radiation patterns. Both these charts together help deduce the rest of the beam in a 3D extrapolation: H-plane, E-plane. The H-plane or azimuth chart represents the radiation pattern as seen from the top. It shows how the signal spreads ahead, behind, on the right and on the left, but not up and down. It provides a flat or horizontal view.